Welcome to my channel Chemistry Class. Welcome back to Chemistry Class. My dear student, I hope you're doing well. So, my dear student, today we are going to study one of the very important topic, which is dynamic equilibrium. My dear student, in the last lecture, we discussed the two important reaction, which is irreversible and reversible reactions. Now let's see how equilibrium is established and reversible reaction and why it is called as dynamic equilibrium. So let's understand step by step. Now basic concepts. My dear student, at the start of reversible reaction, only reactants are present. Mean forward reaction is fast. As product form, they also start reacting back, mean reverse reaction begins. Forward reactions slows down, reverse reactions speeds up. A stage comes when both reactions occur at the same rate. This condition is called dynamic equilibrium. Now, definition of dynamic equilibrium. Dear student, it is the state of a reversible reaction in which the rate of forward reaction becomes equal to the rate of backward reaction, and the concentrations of reactants and products remain constant with time. Also note importance, concentrations do not become equal but they remain constant. Now, why it is called dynamic? Dynamic because both reactions are still happening, and equilibrium because the overall condition of the system does not change. That's why it is called as dynamic equilibrium. Now, characteristics of dynamic equilibrium. The first one characteristic is forward reaction rate is equal to reverse reaction rate. And the second one is concentration of reactants and products remain constant, mean not equal but constant. Third one, possible only in a closed system. And fourth one is reaction looks stopped, but both reactions continue side by side. Now, example of dynamic equilibrium, Haber's process N2 gas plus 3 H2 gas gap 2 NH3. Real student in the beginning, only N2 and H2 are present when forward reaction dominates. As NH3 forms, it also starts decomposing, mean reverse reaction. After some time, both reactions become equal in rate. At this stage, concentration of N2, H2, and NH3 remain constant, and that stage is called dynamic equilibrium. Now, graphical representation of dynamic equilibrium. This is a graph, and this is a forward reaction, this is a backward reaction, and an axis x-axis at the time, and on the y-axis it is a reaction rate. So forward reaction start high, decreases with time. Backward reaction starts at zero, increases with time. Both meets at and become parallel in stage at the stage of dynamic equilibrium. Now, daily life examples of dynamic equilibrium. A saturated sugar solution, sugar dissolves and crystallize, bake at the same time. Both processes continue. Amount of dissolved sugar remain constant. That is dynamic equilibrium. So, my dear student, this is all about today's lecture. dynamic equilibrium. I hope you understand. So if this lecture will help you, then don't forget to like the video, subscribe to the channel for more chemistry lecture, and share it with your friends. Comment your question below. Take care and see you in the next class, inshallah. Thank you for listening.